guys, today we will be discussing about an important concept, that is Zener diode. We have seen the normal PN junction diode. Now we will be considering Zener diode. What is the difference between a normal PN junction diode and a Zener diode? What is this Zener diode? All of you must have seen the stabilizer which regulates the voltage. That also uses this Zener diode. Let us look into this, how it works, what is the difference between the PN junction diode and Zener diode. A Zener diode is a special semiconductor diode which is designed to operate in the breakdown region under reverse bias without causing any damage. We have seen that the normal PN junction diode that can be forward biased or reverse bias, and the reverse bias case we have seen at a particular reverse bias voltage there is a breakdown, and we have seen if it is avalanche breakdown that will cause a permanent damage to the junction diode. But in case of Zener diode the process is reversible and hence it will not cause any damage to the device. So the Zener diodes are specially designed to work under that reverse breakdown condition because it will not cause any damage to the diode. It is named after American physicist Clarence Melvin Zener, who discovered Zener effect, what we have already discussed in our last video. What is Zener effect? How the tunneling of electrons occurs from p side to n side and we are getting a large current for a particular breakdown voltage. This Zener diode, as it is working under the principle of Zener effect, the name is given as Zener diode. Thus, the working principle behind this Zener diode is Zener effect. We have seen in the last video that to have this Zener breakdown, the PN junction should be heavily doped, right? So here in these Zener diodes are heavily doped. Can you recall this symbol over here? Yes, this is nothing but PN junction diode. This is the P side and this represents N side. That's what, this is the anode and this is the cathode. The symbolical representation for this Zener diode is almost same as this. Only the difference is that you have to put two lines over here. After putting these lines, this shape is looking like the English alphabet Z, and this diode is our Zener diode. Thus, just to differentiate between our semiconductor PN junction diode and Zener diode, only here we are putting these lines. If these lines are there, then it is Zener diode. If it is not there, then that is our simple semiconductor PN junction diode. So the symbol is similar to that of an ordinary diode, except the bar is turned into Z shape, and this represents that this is a Zener diode. Now coming to the VI characteristics. For forward bias, the Zener diode works almost similar to this normal semiconductor PN junction diode. Hence, this forward VI characteristic curve is same as the PN junction diode. In the forward bias direction, the Zener diode behaves like an ordinary silicon diode. Only the difference lies in the reverse bias case. So, what is that difference? Let us look into that. When a high voltage across the Zener diode reaches a certain reverse voltage known as Zener voltage or knee voltage, the current increases abruptly. So here in case of the reverse bias, there is a small reverse current up to a certain voltage led up to here, but after that particular reverse bias voltage, the current increases abruptly. Suddenly there is a sharp rise in the current. So here the current is increasing very sharply at this particular value of the reverse biased voltage, and this voltage for which we are getting a sharp increase in the current, that is known as Zener voltage, and it is represented as Vz. And as this position is looking like a knee, that's what this name is also given as knee point, and this voltage also in some book it is written as knee voltage. Here this breakdown occurs due to the Zener effect, that is the tunneling of the electrons from p side to n side. Because the doping is very high, that's what we are getting a narrow depletion region that leads to tunneling of electrons from p side to n side, and due to that we are getting this sharp current over here. Now the region under this curve where this current is almost increasing very high and the voltage is constant, that region is known as Zener breakdown region. And the Zener diodes, they are specifically designed to work in this region. This region means the V, so across the Zener diode should be this V, and the current can be any value rising from, this is the minimum value, this is the maximum value. So within this current range, what is the voltage? That is remaining constant at Vz. That means if the current is increasing or changing, for all the value of current we are getting the voltage at a constant value, right? That's what it is used as a voltage regulator or stabilizer. In the Zener breakdown region, the voltage across the diode remains constant, but the current changes with respect to the supply voltage, right? It has a sharp breakdown as compared to normal PN junction diode. What does this mean? This means this breakdown over here, it is very sharp. In case of normal or avalanche breakdown, you can get little slope is there, but here it is very sharp, going almost 90 degree. The breakdown voltage and hence the Zener region is designed by varying the doping level of the PN junction. Where exactly we want to have this breakdown, that can be adjusted by changing the doping level of the PN junction. What are the applications of this Zener diode? Most of the application of Zener diode are based on the fact that the voltage across a Zener diode remains constant for a large range of current. Just now we have seen in the previous slide that for a large number, I told you that I minimum to I maximum, for all the values of current we are getting a constant value for voltage. That means the voltage remains constant for a large range of current. Most of the application is based on this fact that this is keeping the voltage constant for a large range of current. It is used as a voltage regulator or stabilizer. The function of a voltage regulator or stabilizer is to provide constant output voltage, right? All of you might be using at your home the stabilizers which is providing us a constant output voltage. And here we have seen that the voltage across the Zener diode remains constant for a large range of current, and hence these Zener diodes provides a constant voltage in reverse breakdown region, and that is the reason why these Zener diodes are used as voltage regulator or stabilizer. The next application is meter protection. The Zener diodes are used in multimeters to protect the meter in case of overload. What is happening if some multimeter, some voltmeter, ammeter is there? If you are connecting a Zener diode across that, if a very high current comes through the circuit, that will pass through the Zener diode, and hence these multimeters, they will get protected. So the Zener diode is connected in parallel with meter, and most of the current passes through it, leaving behind the multimeters undamaged. Like this we can protect the devices by connecting a Zener diode parallel to that. Next one is wave shaper. From the name itself you can see that it is shaping a wave. So it is used to modify the shape of an input signal. There are different types of wave shaper. Clipper is one of the example, and this clipper is a circuit which is designed to remove a part of the input signal without distorting the remaining part of the input waveform. What is this? This is the input. Here you can see this is a input sine wave over here, and if you want to remove this part without distorting the remaining part is this. We don't want any distortion to this remaining part, only this should be removed. That can be done by using a Zener diode. So the Zener voltage we can set over here. So after that also you will be getting the voltage constant over here. So it is the constant, above that will not come. This is the output over here. Here you can see this portion of the input is being removed, and hence this circuit is known as a clipper circuit. This is the input and this is the output. You can see over here the remaining part is remaining as it is. There is no change in this part, only this upper portion is removed. Similarly, if you want to remove few from this lower part also, we can put one more Zener diode over here that will remove the lower portion. So here this is our input and this is our output. In the output, we have removed a part of the input signal. Hope you understood what is a Zener diode and how it works under this Zener effect. Today we'll stop here. Thank you all. If you like the content, please press the like button and don't forget to share the link with your friends. Also do subscribe the channel so that you will be getting a notification whenever I am uploading a new video. Thank you all.